Yeah, so I hope everyone had a good lunch. I hope everybody who's online too can see the video. I mean, this is just an example of some of the stuff I'm going to be talking about today with, high definition 3D laser scanning. Quickly, agenda, introduction, we're kind of in the middle of that. Just a quick run through of what is laser scanning. How many people here have worked on projects that involved laser scanning at, one degree or another? All right, I'll just kind of quickly go over that with how it works, how we use it, the differences between scanners, what you can get from the data, and I'll have a couple good, historic preservation case examples. And it's really interesting because when we first started with scanning in 2002, we thought historic preservation was going to be all the work that we would be doing. But as soon as we got into it, we realized that the technology, wasn't there yet. Not a lot of people were using it. It was still very expensive. And over the past couple of years, or past maybe 5-8 years, we've seen a lot of turnaround where we're doing a lot more historic preservation projects because as technology has grown, the costs have come down. And I'll quickly talk about standards. That's something that's really important. So Langen, we're a service provider. We provide laser scanning services, and it's really important to us, about the standards. So that way the end users, the clients, the owners, they know exactly what they're getting. So real quick, my name is MatthewSipple. Yeah, she described. I have a degree in surveying technology from NJIT. I'm licensed in New Jersey. I'm actually based out of the East Coast, but as you can see from that little map, those are all the blue areas are areas that we've done projects in. And, a lot of the international, pretty much all of the international projects have been for historic preservation. And, either myself or one of my crews have been in, all those countries except for China. We weren't able to get into China, but that's something else. But I've been laser scanning since 2004, but it's been really taken off since around 2008. That's when, Revit came out, architects started doing a lot more things in 3D, the technology grew, and due to the, the crash in the housing boom, a lot of our work went from, new construction to existing construction. I'm also a member of the USIBD, which I'll be talking about later. That's the United States Institute of Building Documentation. And that's an organization of service providers, architects, contractors, owners that have gone together over the past 3 years to try to put together some standards for scanning. So real quick, I'm not going to read through all of these, but what is 3D laser scanning? We still get that question. It's been around for a few years, but a lot of people still ask, what exactly do I get out of it? So the scanning, because it's the verb, it's the process of acquiring millions, now we get millions of point data, XYZ, resulting in a 3D point model. Now, this could be at a very small interval, 1/8 of an inch or even less. We're talking about sub-millimeter resolution, which I'll talk about those terms later on. We like to say they're accurately horizontally and vertically to 1/8 of an inch. The manufacturer will tell you that one scan is accurate to sub-millimeter, and a lot of times they're right. We like to always quote about 1/8 inch because, as a surveyor, we know that when you go around an entire building, there's always going to be a little bit of error, so we try to minimize that error. Another really important part that we've been doing a lot of this, especially on historic preservation, is the 360-degree photos, and actually the Nodal Ninja kit that Caitlin mentioned. That's something that we use a lot. We use a lot of those photos to make true color point clouds, which can help you differentiate between different materials, different colors. It really helps out with the point cloud data. And then we take all that point cloud data and we can reduce it into 2D CAD drawings, AutoCAD, any of the the Bentley products, MicroStation, Maya, 3D Max. All this point cloud data can get brought into any of those formats. And as more software vendors are now opening up the point clouds as well because they're seeing a lot of the potential of that. So real quick, this is just a quick video. Let's see if it works. Worked before.
Click on it.
Yeah. A video, basically just a video of how the 3D laser scanner works. I was thinking about bringing it, but you don't really get to see the whole aspect of what's going on. So that laser, that little green laser beam is shooting out, and the newer ones, they could say get up to 1 million points a second. It's shooting data, and it's measuring the horizontal and the vertical angle of every single point in the distance. So this isn't a really lovely facility. This is a video that one of the manufacturers made, but it records the distance and the angle every time it takes a shot. And as you'll see, you do this, millions of points a second, hundreds of thousands of points a second, you end up with a big 3D point cloud, which is XYZ values of all the points, and this is what basically we get out of the point cloud. Now, this was obviously done with a couple scans, and I'll talk about how we put that together, but this is essentially what, basically the laser scanner is. Here it is in true color. This is, the photos taken in the field. So 2 important terms that we always want to talk about, and we always put this right in the beginning, is accuracy and resolution, because a lot of times someone will say, well, I want to see everything, 2 inches and above, or it has to be accurate within 2 inches or above. And the terms sometimes get confused, accuracy and resolution. So accuracy is, how accurate that point is in real space. And a lot has to do with range error, has to do with the accuracy of your vertical angle, your horizontal angle. There's a lot of different things that come into play, and also your error when you're trying to stitch it together. Resolution is more about how far apart your points are spaced and how big is that point. Different laser manufacturers have different size laser points, and you can see where the difference in the data. So right here is a scannable wall. So on the one, that's it's much smaller laser pointer. The second one is a much bigger. The further the wider the resolution, the less likely you're going to see where that edge is. Here's another good example of accuracy and resolution is, resolution, that right there is a 2-inch resolution. Now, if you want to see grout lines in there, you're not going to be able to see that with that kind of resolution. All right, skip that one. All right, so, and there's also based on the size of the laser, there's also differences in how the scanners pick up the data, which has become more important because as technology grows, now we're using Scanner A. That's the more expensive scanner, and you can see how crisp that point cloud is and how close that is to what those actual pipes are. This is a pipe run. That's the picture in that corner. You can see this is a test, independent test of 4 different scanners. You can see you'll get Scanner D. That's a really cheap scanner. There's a lot of those scanners out in the market now, but you can see the kind of error that you would get from that point cloud. Now, that's just based on the data hitting that edge of that pipe and not really knowing where it is and kind of making an assumption. Here's another example. This is actually a State House project that we were working on where we were mixing different types of scanners, more as a test drive. And you can see where, this was a granite floor. You're getting about 1/8 of an inch of noise. This is what we call noise. From one scanner, another scanner, which was taking maybe 10 feet away, you can see we're getting closer to like 1/2 inch noise. And when you're doing a model or you're creating something, that becomes really important because you want to know, you want to reduce the amount of noise to know where the object really is in space. So how do we put all that together? Every time you do a scan, and then you go to the next slide, you do another scan. How does that all come together? And that's really important, especially when you're hiring a service provider. You want to make sure that you understand how they're putting it together. And it's a process we call registration. We still use a lot of targets. You can see right in here, the paper target, like these black and white targets. That's used in a lot of our scans, and that's how we coordinate from one scan to the next. There's a lot of new things coming out where people say that you don't need to use that. As a surveyor, we like to have that because that gives us a check. We can go out there in the field and we check those, we measure those using some other different tools, and we'll have a check on our end to see if there's any issues that are going on with the registration or if there's any problems. Because the worst thing we hate to hear is somebody goes back to their site and says, hey, it doesn't match what's actually out there. So that gets us in a lot of trouble, both financially, legally, and it just really looks bad. So here's an example. This is one of the earlier projects we've done at St. Patrick's Cathedral. Every one of those triangles was our laser scanning setup. While we were doing the scans, we set up the targets, which are these little red X's. Hopefully you guys can see that here. So that way, and there's common points between every single setup. So then when you go out there and you do your setup, you catch everything all around you. Those targets are used to coordinate that together. This is a simple example. Here's a more kind of complicated example of when we're doing a floor of a building. And you can see all those X's and circles are where we do laser scanning setup. So that becomes very important, when you want to tie all those together. So here's the process. So initial registration, you bring in all your point clouds. They all come in right on top of each other. Every time you do a point cloud, it takes where the scanner location is at the center of the universe. And you get a stack of points right on top of each other. And also, all the elevations are different because as you move the scanner around, the scanner moves up and down. Every time it thinks it's 0, 0, so all your elevations are all over the place. After doing the registration using the targeting, you get a much better, nicer looking point cloud that's actually accurate to what's out there in the field. So what does this data look like? You know, that was this right here is a good, you know, floor plan view of it, but what does that actual data look like? And it's just really come a long way. So, you know, here, this right here is just an example. This is actually a viewer that we have now that sits on our web platform that you can look at that point cloud data. And this is done using a 3-minute scan. And you can see, hopefully people on the interweb can see this too. But you know, you can see like the sheet metal. You can see the ridges in that sheet metal. You can almost see to like the light bulbs. It's pretty incredible the amount of data that you can see from this point cloud now. And here's a scan that was done in true color. This was actually done for the Trinity Church in Boston. And hopefully you guys can see that. But you can actually make out the lettering. You can make out the crowns and the crenulations in there. So you can really see a lot of data. And this, again, was only done using a 3-minute scan. You can even see the lines in the granite over here. So some of the advantages of laser scanning is that you can acquire, you know, especially now, a tremendous amount of data in a relatively short amount of time in the field. The data, like I mentioned, is coming out. It's more compatible in a variety of platforms. It's digitally, I probably should say digitally archivable. That's become really important with some of our preservation architects. They want to be able to put this in a format. So we're able to reduce that down so it's just XYZ values. Of course, it's billions of, you know, XYZ values, but it's something archivable that maybe in 10 years, somebody could still go in there and figure out how to open it up. It's non-invasive, non-tactile, non-destructive. You don't have to touch anything to scan it. You don't have to, the scans are eye safe. I mean, it's really just a pulse of light. We've done a few museums. We only had one museum that did not want us using a certain type of our scanner because they weren't happy with the class laser. But for the most part, we've never had any issues with the eye safe. It's eye safe, it's non-destructive, and you don't have to touch it, which is important for, you know, as I said, like dangerous situations. We've done a couple clock towers in New York that are falling apart that we were able to be, you know, a safe distance away and get the data that they needed. We didn't have to get up right next to it and risk getting injured. It could be shared cross-discipline. So I know most of the people in here are architects, historical preservation architects, but the amount, like, so that one example I showed with the lighting and had the pipes in there, later on that can be shared with an MEP, you know, engineer to talk about the pipes and figure out what to do with the pipes. Another big important, where you saw a lot of those international projects on there, is that you don't have to return to the site. Somebody sitting at their computer in California can pull up the point cloud of a, you know, building that was done in San Diego or in Puerto Rico or in Europe somewhere and look and take dimensions. You don't have to go back out to the site. The data's all there. Some of the disadvantages are, and I always like to throw this in there even though my boss hates it, is that, you know, it doesn't do X-ray. That's a question that always comes up. Somebody says, oh, you set that up and you see the studs in the wall. Haven't gotten there yet. There's some cool stuff where people have, you know, I think you'll see that tomorrow, like, you can do waves and GPR, but we still haven't got to that point yet. Requires a stable platform. Now, going back to my example I gave of the clock towers, we actually have a tower that we're doing a site walk next week where it's falling down. It's not structurally safe, so we can't actually go in there, but you still need there's still ways to do a lot of scanning. That's why I say most of the time. We actually had somebody in a crane bucket with a hand scanner scanning the side of a castle once to get some point cloud data. You know, it wasn't the best way to do it, and this client had a lot of money, but for the most part, we say it requires a stable platform. The resolution is not fine enough to detect hairline cracks or sub-millimeter features. So the question we get asked a lot is, hey, you know, there's cracks up there. Can you guys see that with the scanner? And we cannot see that with the laser scanner yet at this point. You know, there still needs that hands-on kind of look at it. It does take up some computer drive space. I mean, the data, it's gotten more compressible, but it still takes up some space. And then depending on your case, you know, we like to say this a lot, bang it to fit, paint it to match. That's not a really good use case for laser scanning. You know, it gets dimensionally accurate, but if you're in a situation where it doesn't really matter, the contractor's going to go out there and fit it in there anyways, you know, fit in the wall anyways, it's not a best use case for laser scanning. So what do we get out of the point cloud data? So we'll start with our basic deliverables. The first deliverables that we're doing, and we still do a lot of this, is 2D elevation drawing. You know, and you can really see the amount of detail that we can get on these buildings. This is a hotel building in Manhattan. You know, you could really get down to the fine details and see the crenulation in the building. Floor plans, you know, that's a basic deliverable from laser scanning. And we've even gotten into a lot of model deliverables. Now, I'll talk about a big model deliverable later on. We haven't seen too much of this in historic preservation. You know, this is a lot of mechanical modeling. This is the, you know, interior architectural plan, but it is getting to that point. And digital records become really important for us. We partner a lot with a college out of Florida, and they capture this one, Dr. Lori Walters. She specializes in capturing buildings that were built between the 50s and the early 70s for historic preservation. So that way there's a digital record of that building before either a developer tears it down or they add on to it. And she also incorporates that with oral histories. And she's actually done a couple cool projects where she creates oral history tours. In the beginning, I was showing the New York State Pavilion, where they have interviews with people that were at the fair when it was really there, and they record and they talk about how, like, there was a hot dog stand over there, and they talk about, you know, how they felt when they walk in there. And she's done that with a few buildings, and that's become really important. Actually, yeah, there's a video of the model. So from this point cloud, her team built a model, and this is what was used in the virtual reality with the headset and hand controllers, and you could walk around and you could look at different parts of the facility. And then 3D prints, which I had a picture of, but we've had some requests for our expositions and different buildings to have it as a 3D print just as a record. So there's always a lot of misconceptions, and this is a lot of stuff that we've heard over the years about, you know, 3D laser scanning. Number one is always, my site's not big enough. You know, I don't have that kind of budget. We could do anything from a small window to, you know, entire neighborhoods, which you'll see as I show the examples. It'll cost too much money. We heard that a lot, and that still comes up a lot, but, you know, the excuses are, oh, it's not going to be worth it. We won't be able to use the data. We can't do anything with that data. So as technology has developed, there's been a lot more compression engines that have been able to really reduce the size of the point cloud data. A lot more software can use that point cloud data. It will take too long. We hear that a lot. You know, our crews, even though it takes some amount of time, it really saves on the back end from going back out to sites, having to do hand measurements if there's a problem during construction. And our favorite is, there's no way we can ever scan that. And this isn't a project that we were involved with, but I like showing it. This is a crew from the National Park Service scanning the face of Mount Rushmore. They did this a few years ago with SciArc because they wanted to preserve that as, you know, the face was deteriorating. Obviously, this is not, you know, the cheaper way to do it, but if you have to do it, there is a way to do it, and guys that scan love to figure out crazy different ways. So here's some example projects that I'll go through. And it's actually, the first project I'm going to bring up is this church, which is really interesting because I actually took it out of, you know, I didn't really haven't talked about it in years, and it actually came up again at another conference we were at, where there was an architect who actually worked on this. So this is going back to 2004. It's the old, you know, there was a plumber on site installing a hot water heater, you know, hits the wrong thing with his torch. The whole church ends up going up in flames. This is a church that was built around I want to say the 1820s. I could be wrong on that. But the whole church burned down, and the only part that was left was the stone entrance. And the architect wanted to recreate the windows and the doorway and the entrance to the church because everything had to get demolished. It was falling down. And they called us up, and we went out there, and you can see, like, our scanner right there. You know, that looks nothing like what we have now. You know, this kind of, like, makes me laugh. You know, I mean, the thing was huge. We had to have a gas power generator operated. We had to have a big computer plugged into it. So it was a whole production. But we were able to scan this. Now, keep in mind too, this took like maybe 6 hours of scanning, and it's a very, very small area that we had to scan. But this is also 2004. This is the resulting point cloud. You know, we thought we were pretty cool, you know, cutting edge. Then we went to the deliverable phase, and it took us about, I would say, about 2 weeks to make this drawing of the window. This ended up being the one window they wanted to preserve. It took 2 weeks to do that just because it took forever to AutoCAD to load in all the points. But you can see from these plans, and we actually showed this at, like I mentioned, at the other conference, and there was an architect in the crowd that says, "Oh, I worked on that building." And you could see, he showed us some pictures, and this is what the building ended up turning into at the end when they rebuilt the building. They were able to replicate the stone patterns of the original entranceway. and use that and carry it on for the entire building and recreate the building. So it's kind of a cool story. Our next example is St. Patrick's Cathedral. It's a little bit bigger, a little bit bigger deal. But this also spans about maybe 10 years of working on this project. So how this project came out was our company does a lot of geotech work, and we had our engineers were out there drilling test pits, and they saw this whole like catastrophe happening where they had a person in a cherry picker on the top of one of these spires with, no joke, he had a 100-foot tape measure with a rock taped or a brick taped to the end, dropping it down and then trying to record the measurement of the height of all these spires. In the meantime, he's yelling at somebody else on the ground to tell him to move the tape over here so he can go measure that spire. So the engineer went over and started talking to him and said, "What are you guys doing?" "Oh, well, we need accurate, dimensions of the building because we don't have any kind of accurate building." So we ended up talking to us, the scanner, so we ended up going out there and laser scanning that. Now, these architects, they didn't have a lot of budget to work with. They figured they'd be there for a day or two, and this was actually on day 3 of their lift rental and measurement crew out there, and they only done a quarter of the building. So we did a laser scan, and our solution for this was we just created a 2D image, but we were able to scale it correctly because we had all the survey control and hand that off to them. So it's kind of difficult in this lighting to see, but it's not the best. This is a few years ago. But from that data, we were able to provide that, and the architect was able to do their final drawings that were all dimensionally accurate. So here's an example. This is the overall point cloud, and there's an example of their final drawings, which were really gorgeous looking.
How much processing does going from the point cloud data to the final drawing, do you actually have to manually remove the extra points that are extraneous, or how much work does it take to turn it into that?
It's more like reverse engineering.
Yeah.
So in this case, this was actually just handed off to the architect. I mean, I think he spent 3 weeks on it, but he was very, very detail oriented. But a lot of it is you're just recreating it in whatever platform you're working in. So, in this case, they took the point cloud, he brought it into AutoCAD, and then he just traced over the point data.
Oh, okay.
He didn't reduce any of that, take any points out. Here's another example. Now this is a few years after that. This is when we started going inside. So this right here is it's called a tin building. It's in New York City, and the client here had to preserve this because it was historic preservation. But they didn't want it here. They didn't want it right here on the FDR drive. They wanted to move it back. It was a really cool building. So we went out there and we scanned it because he had to record, basically have a documentation of what building was there so he could take it apart and then reconstruct it further down the pier. Interesting part about this was it was the first time we went inside and we're doing different levels. So here's what the point cloud ended up coming out at. We had enough data in there to do all of our drawings, do all the plans. And here's a section drawing of the inside. So this is 2 levels of the interior of the building. I also like bringing this one up because it took us, this is in 2008, it took us 3 days to do all of this. We actually got called back out there a month ago, and we were able to do the entire first floor in about 6 hours with the new scanners and get a lot more data. So the scanning has really come a long way. It's really moves a lot quicker. You get a lot better information now. So I know I kind of dropped off St. Patrick's Cathedral. Coming back to it, so that was the exterior work. So exterior work is underway. This is going to 2014 now. Some questions started coming up. So I don't know if anybody was following that, but they did a huge restoration project. As they were working through it, they started going inside and doing some restoration work on the inside. So we were asked to come back out there based on our history out there and do some work on the inside. And with our newer scanners, we were able to really blast it out and really help the structural team, the mechanical team, and the architectural team. So here's a couple pictures of us who were scanning in the main sanctuary area. Now the structural team, they wanted to understand the thickness of the ceiling plaster. And everyone thought, there was no way to do that without drilling, but the cathedral did not want any kind of drilling going on in their, ceiling because they're worried the whole thing would just collapse, which I don't blame them. So we were able to run survey control, do scans in the attic, which ended up helping the structural team because then they could look at the beams in the ceiling and put it all together, and we ended up with a point cloud that looked like this. So this is just a slice through the middle. We took photos inside the main sanctuary. We didn't do any photos. The lighting was really bad in the attic space, but you can see how this all kind of came together. And this was maybe a process of about a week, which the original exterior cloud took 3 days to get. This took a week. It's really not that much time. Here's some other snapshots of just the different views and all the data we were able to get out of that. So, and here's a quick video, which may or may not run. Let me try doing that. All right, it's not running. All right, so I'll skip right ahead to, this is something, much more recent project, but this is also part of our digital record. So this is the, should be TWA Flight Center. For those of you who know, it's an Aero Sarien. Is that how you pronounce? I always mess up his name. Sorry. Building. He designed this building. This is 1962 when it first opened. It was a really unique building. You look at it now, like it does. That site does not look like that. So here's quick view of the drawings that were made. There's only a handful of these drawings that were in the building. Not a lot of good record of it. And you can see right here, there used to be two tubes, they call them the tubes, that go out, and that's where the airport terminals the airplanes used to get picked up. Fast forward to 2016. In the meantime, JetBlue decided that they didn't like, just using this, so they built this whole new terminal out here and kind of cut off this building. And this building, as a historic preserved, was just sitting there empty, vacant. There was a developer in the area that got this great idea, because all this whole space in here is all empty. He's like, you know what, I could put a hotel in there. Well, our friend Dr. Lori in Florida caught wind of this, and she wanted to scan this building because she had no idea what was going to happen, and she was worried that anytime anybody touches anything or wants to touch it, they say, yeah, we're not going to mess with it, but you never know when somebody goes in and knocks down a wall or takes out a side. So we teamed with her team, went out there, and we scanned it. Oops. I hit the wrong button. So we scanned it. It was maybe a 2-day period. We scanned all the areas of great historical significance. This is the main entranceway. Was a really cool building to be in. And then here comes the developer. This was the planned hotel that they wanted to put in. I really have to thank them because they're allowing us to talk about it. So they came in and they started talking to our company, and they said, hey, you guys have all this scan data. Can you guys get everything in this data? Because my architect needs to understand what this whole building looks like so we can tie into that. So moving forward, we ended up going back out there and we did some more scanning all the nooks and crannies, all the areas, and we saw a lot of cool things. We actually got on the roof. They were able to get us up on the roof. We ended up doing around 575 scans total for the entire building, mapping it just not for historic preservation, but also for architectural plans, and we ended up going to a 3D Revit model for the architects so they could use for their design. Part of this as well, we ended up, they wanted a lot of topo on the roads on the outside, and being that it's a busy parking lot, it's very hard and very expensive to get road closures. So we actually rolled out with our mobile mapping team. We have a mobile mapping team that does a lot of work in the back of a truck, and they were able to scan around the entire outside on the streets to get all of this information and tie it all together. There's just couple quick snapshots of the point cloud. Like I said, this is like a photo rectified 3D point cloud. You're able to see the red carpet, tell the differences in the materials. And this was the final model deliverable that we ended up providing to the client. This isn't a small project, obviously. This is a really big project, but it's really cool how we were able to get all this stuff and put it all together. I think there's a spot where the roof pops up, or we go inside.
Are you able to reveal ballpark how much the project cost the client?
Yeah, I mean, we're in the neighborhood. It was over $100,000.
Okay.
We'll just say that.
Thanks.
But this was also very high end, and this is also a very difficult structure to model inside of Revit. Anybody here that's used Revit knows that it does not like curved features. It does not like existing conditions. We like to say we always have to break Revit in order to work with existing conditions. But right now they're out there, they're in construction, and this is being used, and they're actually still not even touching it. So.
And how accurate?
We say we're saying it's an 1/8 to 1/4 inch. So. All right, here's another project. I really don't want to give out the name because we're kind of supposed to keep this confidential. But this here is, we're talking about different scale projects. This was a very large scale project that we did last summer. So the main area of focus on this project is this square right here. There's a couple buildings in here. Now this kind of talking about the GIS part of this too. This is actually going to end up going into that type of scenario. But our client on this one, he's an architect that sits in Philadelphia. He wanted all this information about this entire area. So this is the Historic Preservation District. He wanted to know what every one of those buildings are, and he wanted it before he even sent teams out there to go take a look at it. So he came to us and he said, I got this 1.5 square miles of space. I don't care exactly all the details on all these buildings, but he wants to know like down to like the mortar joints on these red buildings in here, pretty similar on these yellow buildings. Everything else, he just wants to know how high they are, how tall they are. So this was a really unique project for us. So we had to do a lot of thinking, a lot of planning to come up with how to approach this project. Doesn't help either. This was the center of the town. It was very busy, and it was during the summer, and this is a really big tourist attraction in the state. So it was really, really busy. There's both interior and exterior scopes, and the accuracy is super critical. We've done quite a few projects for this client, and he wants everything to be within the 1/8 of an inch, if not less, 1/16 of an inch. So it was a very high-end type of project. So we decided to come up with this combined approach where we would scan everything on the ground within the yellow, scan everything that was within the white. We'd use our mobile mapping team because that's going to get you the road grades, that'll get you the building heights, the building sizes. And then for the super fine, where he wants to see individual stones and how they're placed, that was done by somebody else using photogrammetry inside of those buildings. So here's a quick view of our field team out there and work. We did this this actually took a while to do because we had to scan the entire grounds, but we were out there for about 5 weeks with 2 teams. Scanning, you can see over here all the people. We were doing scanning from lifts. I said that stable platform, that right there, we always prefer using scissor lifts where we're able to scan the tops of all these areas. You can see right here, we had to do it in off hours to beat the tourists. Here's some other pictures. Now talking about the camera kit, here's some good pictures of our guys using the camera kits in the field, the Nodal Ninja. That's what the Nodal Ninja looks like when we're using that in the field. And we have a special bracket system that's made so the focal point of the camera is exactly at the same spot as the focal point of the scanner, which really helps when you're stitching these images together. Here's one of our field guys explaining it to one of the reenactors, what exactly he was scanning, which is always a fun picture to throw in there. Here's our mobile mapping team that was out there. This is our truck that we usually bring, that we had on site there, but there's a lot of areas where they had sidewalks, so we couldn't exactly drive the truck through, so we actually ended up mounting it on top of a rental buggy that we were able to drive through some of the streets, some of the pedestrian areas. We had to have the Rangers, which they're still called the Rangers out there, but the Rangers were escorting us through the streets. But we were able to catch a massive amount of data to use for the team. So here's just some example clips of that point cloud. This is like the terrestrial scan point cloud before we integrated it with the mobile cloud. Some close-up views, and you can get down to seeing like the individual grout lines in there. That right there, that's just an overall view of the mobile cloud. So what do we do with all that data? Well, we handed it off to the team, and the modeling team ended up creating some really nice looking Revit models out of that. So here's system snapshots. Now, the modeling was done by somebody else, but he had 7 teams working on this for 10 weeks to create this modeling. But it's pretty incredible. We look at some of the modeling. And so for those overall buildings, like what happened, that's some of the other buildings, but what happened on the overall with that mobile data, that data was reduced into this, which is a very close to GIS, kind of Google Earth heights of the buildings, but that's what was needed for this project in the studies. So now I'm done with it. These are the examples. So real quick, just want to talk about standards because that's something that always comes up. And I'm sure maybe some of you can kind of relate to this, that standards are always a moving target. There's different level of details, different RFPs. Even come to us when people ask us to scan something, there's always different level of details, level of accuracy. So, the question always comes up about standards. So here's some of the known standards that are out there. That's RICS, which is the Royal Institute of Chartered Surveyors, which is out in the UK. They have a really good book about preservations, measures of buildings for historic preservation. Now, I kind of mentioned I was licensed in New Jersey, but just New Jersey, because there's not a lot of oversight right now, especially on the government side of the type of work like the laser scanning work. It's kind of still the Wild West. There's not a lot of laws out there. Different states look at it different ways. A lot of state boards now, state boards of surveying, are actually looking more at drones and topographic data versus, building scanning, because that's just something that surveyors have never really had on their radar before. But it's always important because, as a surveyor, if I certify something that's an 1/8 inch accuracy, that's going to be different than, some guy off the street, like a pizza delivery guy, saying, that's an 1/8 of an inch. So, these are some of the different standards that you should probably be specifying when you send out RFPs. AIA, that's something that always comes up. People always, hand out AIA, like, we want this to the level of LOD 200, LOD 300, but that doesn't really capture accuracy. If you ever actually read through those standards, which we have a few times, there's never anything about their existing conditions and how accurate are those existing conditions. The same thing goes for the BIM forum. If any of you guys members of the BIM forum, they have a LOD, which is level of development of models, but it never really addresses existing conditions. So that's why earlier on I mentioned the group USIBD is the United Institute of Building Documentation. It's really a group of architects that were burned by, bad projects, service providers. We have a couple vendors in there as well, and we put together this guide, level of accuracy, to really use to, when you're specifying a project, to put in your contract, your RFPs, that you want to a certain level of specification. And I think it's free to join, but you got to pay to go to some of their events. But it's a good organization to be a part of. We had just come out with our second version of the level of accuracy, and it's really important too for this group is that one of the big things we added was we added a heritage toggle box in the standards. So how these standards work is you go through there, and it basically, using the AIA specifications, breaks down every type of object that you could be modeling, and in there you can tell them what type of, how accurate you want it to be. And for heritage, it actually goes a little bit more accurate, a little bit more precise than, just the standards. And that helps you control your costs, and it also helps control apples to apples. So we always like to throw this in there because it's kind of funny. So let's say you want this, tattoo of a Pegasus, a winged Pegasus. Well, you go around and you shop around and you find the cheapest, let's say you want to do a tattoo. You find the cheapest tattoo artist. What you ask for might not be what you're getting. So, and we had a couple architects that we know really like that, because that's exactly what's happened to that. So, just to summarize, some consideration, for laser scanning use and going out and getting vendors, always look at your project requirements, what deliverables. You really get to have all that worked out beforehand, site accessibility, how much cost you're looking at it. And it's really important, one of the pieces of advice we always give out to architects and owners is, look for experience, look for, a service provider that's willing to educate you, somebody that has a lot of options, somebody that's done a lot of projects like that, because even today, we still get there's a lot of different people out there with a lot of different skill levels. So if anybody does anybody have any questions? That's pretty much wrapping it up. Yes.
That was amazing. You had mentioned one or two projects about handing it off to the modelers. I've seen and worked with a lot of point clouds, and then you gave the example of the architect hand drawing.
Yes.
What's the state of the art now in getting the point clouds into the regular?
So right now, yeah. So I didn't talk too much about the modeling side of it. So we used to do a lot of our own in-house modeling, like. So architects, and we would get hired to do the point cloud and the model, which was really good. But now we're seeing a lot more, that's sort of transitioning now to a lot more architects are able to use the point cloud because of an Autodesk product called Recap. So prior to 2013, anytime we had a point cloud, to get it into any Autodesk product, you had to run through this conversion program that really dumbed it down. The architects would get it and be like, I don't see anything you got, I don't see any of this stuff. But then we show them our point cloud, like, that's not in my point cloud. But now with the Recap, they bought a company that was able to compress it to a much smaller size, and it works across all Autodesk platforms. We're seeing a lot more of that because, a lot more architects, they like to build the model, they want to build it and focus on what's important to them. Whereas as a service provider, we're going to make everything as accurate as you want, but the architect knows, like, we're not worried about what's happening over here. Our main concern is this side of the building. When we're brought on, we don't know that, so we'll spend all our time making sure, this door over here looks right when it doesn't even really matter for the project. So we're seeing a lot more of that going on now. One
more question.
Yes.
Could you speak to the cost of this? Because I can see this as a huge resource for much smaller projects than that.
Yes. So the cost, it's always a conversation and a mix, but the amount of data we're able to capture, so like one day of scanning, we would equate to about, around $3,000, $3,500 of, fee for one day of scanning. But the amount of data you can get from that one day, there's been a few projects where what used to take us a day, we could actually do in like 2 hours, and it's a lot less. So.
You have a minimum billing? Like 8-hour day?
No, we try not to. Depending on the project. We've done a few sculptures where, it takes us 2 hours to do it. So we're just going to charge them for the time on site, and then maybe an hour or two in the office to put all that data together. But it's really, when I say that the costs have come down, the amount of data. So like that tin building I was showing you, like I said, we were out there for 3 days doing that. We got what we could in 6 hours, and we got a lot more data. So we're getting a lot more information now in a lot less time. I have business cards, but.
What scanner are you using these days?
So we do a lot. We have a lot of Leica products. That's just what we started out with. You're going back in the years, like when they came out with the Scan Station 2, we bought that as soon as it came out because it was able to go. Scanners used to only be limited to like a 45-degree window, and there was the first scanner that goes up. We still have a lot of Leica scanners. We do have a couple of Faro scanners, but like some of those examples, some of that bad data is coming from those different scanners. And the P40 is one of the best scanners we have right now. Scanners are getting smaller and they're becoming more compact. I actually have a picture. The new one that they come out with is not much bigger than this water bottle. So it's kind of crazy.
And I have a question about the
Yes.
TWA project, because I noticed you were showing an aerial sort of the site in 3 dimensions. And I know one of the big weaknesses of laser scanners is that you can't scan anything that is not visible from the viewpoint of the scanner, right? So
Yes.
you can't really get the roof structure unless you mount it on something that's in the air.
Yes.
Do you, if you had to fill in that data, would you do something like photogrammetry or send a drone up, or what would you do, or just make a educated guess as to?
Well, yeah, that's actually an interesting question. So a lot of it depends on the site. We just did a project in Miami where we actually used the drone because we were in a safe airspace. We weren't in any restricted airspace. We used the photogrammetry to fill it in, and it actually came out really, really nice. I just didn't have a chance to have it for here, but. Oh yeah, sorry. So the question was, to fill in our roof structures, would we use like a drone or photogrammetry? We would do that.
Right.
We couldn't obviously do that at TWA because it's
At an airport.
it's at an airport, but we can certainly add it, and it's done a lot for us. So.
We get on
Oh.
the roof of an adjacent building.
Yes. If we were able to get on the roof of an adjacent building, we could always scan from there. We always like to do that because that helps getting different perspectives as well. Like that roof, that was at the TWA Flight Center, that was poured concrete. So we really had no problem whatsoever getting on there. And actually, what was really funny was the field crew, their biggest disappointment was, they look at this nice curved structure. And when they actually went out there on the roof, they actually saw that everything was just 4x8 squares. And they like blew their, it just kind of took all the fun out of it. So, yes.
For the mobile mapping unit, are you still mapping from fixed locations, or is it mapping as it's moving?
So yeah, so the mobile mapping system, which I'll show a video of that, but it's not a fixed. There are some systems out there that are fixed that stop, but our mobile mapping unit scans while it's driving, and it has a lot of internal calibration. There's a accelerometer, there's GPS in there to detect where it's going, the direction that it's going in. So it actually is just, it's continuously moving. It has to actually keep on driving. If you stop it, it always ends up with problems. But that's how that system works. Yes.
I've been hearing some about and looking into the E57 file format, which is an ASTM
Yes.
standard format. I just wanted to hear your views on the advantages or issues with that file format.
Yeah, so the question was about the E57 file format. That's actually one of the premier, I would say premier, but one of the more universal point cloud data type, like data storage files, because it can end up getting broken into like an ASCII points file. So we do a lot of that, and a couple of our clients that are really concerned about archiving stuff, for posterity, they recommend the E57. And we recommend that too, because you get all the different values of the point cloud data. The one limitation we found is that some software manufacturers don't include certain parts of data in the E57 format, but I know that they're working on it. So